Hey, what's going on, guys? Let's do this problem right here. The question is asking what is the potential of the battery and the current through the circuit, and what will be when the 4 ohm resistor is replaced by a 999 ohm resistor. So let's do this first problem, right? The first question. So whenever we try to find the current, we use this formula: I is equal to V over R. And usually whenever we have something like this, we pick this one, right? We pick this one, right here, and this is 10 volts, and this is 4 ohm, and this is basically EMF, that means electromotive force. So that is given by 10 volts. So 10 volts 4 ohm, we use this equation, Ohm's law, to find the current. So here, if you substitute, you get 10 over 4 is that's equal to 2.5 ampere. But in this case, it's not going to be like this, because since we have internal resistance over here in the battery, we have a 1 ohm of internal resistance, so we have to add this one with this resistance, and then we have to calculate the new ampere. So this one doesn't work. So the answer is going to be, let's say, actual is going to be V over R. So here V is going to remain the same, that's the only words we have, but R, we have to add them together, and that's going to be the new resistance, that's going to be 5, right? So R total, so here we are going to have 10 divided by 5, and that's going to give us 2 ampere. So that's going to be the actual current when we have this situation. So let's see how we can find the voltage using this one. To find the voltage actually, this is not not the voltage that's going to be measured. Due to this internal resistance, the voltage measured is going to be different. Let's see how it's going to be. So we can use this formula, that is electromotive force minus V drop, right? V drop, and electromotive force is going to be 10, but let's rewrite this one in different way. V is equal to IR, right? We know that V is equal to IR from this equation. So here it's going to be, V drop is going to be due to this small resistance right here. So that's going to be I small r, I actual times small r. We know the I actual right here. So that's what we are going to apply. So this is going to be 10 minus 2 times R is going to be just 1, right? So that's going to give us 8 volts. So that's going to be the voltage measured. And from this one, we can measure the new current. So new current is going to be simply V over R. So this is going to be 8 volt divided by divided by this 4 ohm. So we calculate this voltage right here, measured voltage right here, divided by this 4 ohm, and that's going to give us 2 ampere, right? So that's going to be the current. And let's do the second part. What will be when the 4 ohm resistor is replaced by a 999 ohm resistor? So here the case is going to be different. So what's going to happen is, when we calculate I actual, before we just add 4 plus 1. So here we are replacing the 4 with 999, right? So this is going to be 10 over 999 plus 1. So here we got 4 plus 1, that's how we got 5. So here 999 plus 1, that's going to be 1000, right? 10 divided by 1000, and that's going to give us 0.01 ampere. So this is I actual. From this one, we can calculate the voltage measured. So V measured is going to be electromotive force, that's E, minus I R due to this internal internal resistance. So this is going to be IR, internal resistance, and then we have 10, and we have calculated the new actual current. that's going to be 0.01 times 1. So that's going to give us 0.01. It's almost like 9.99, right? 99 volts. So that's going to be the voltage measured when we replace this 4 ohm with 999 ohm. And that's how we do these kind of problems. I hope you guys find this video helpful. Thanks for watching.